Hello and welcome to Main's Gains. This is my channel. My name is Christian Quartermain and I am a student dietitian studying a master's degree at the University of Nottingham in dietetics and nutrition. I am also, alongside that, a qualified personal trainer. This video today is a continuation on with Metabolic Mondays, and in this series of Metabolic Mondays, progressing on to the next slide now, pause and resume. Every time I jump slides, it stop-starts, so that is why I might bob about. 1 minute I might be here, next minute I might be here. Without further ado, key organs in energy metabolism. This week's episode is on the intestines. We will do it the same as we did with the liver, where I will separate it into two parts. This is part one of the intestine. The contents page. Where is my laser pointer? Hold on a second. There's my laser pointer. I have structured this page in the exact same way that I structured the video on the liver. I feel that if these episodes are, the episodes in the series are formatted in a similar manner, that it's easier for those viewing to follow it, and if there's a specific part that people would like to jump to, they'll know exactly where to go. The first slide is what is the intestine, what it does, what its roles are, and where it's situated in the body. Then we will move on to the intestine's role in the metabolism. So some of the processes the intestines goes through after you have consumed a meal. Once we've looked at some of those processes, we will look at the impact this has on your body utilizing substrates. In this video in particular, what I mean is we're going to look at things like absorption rates, gut transit times. Unfortunately, when we consume a meal, we don't necessarily absorb 100% of the nutrients within that meal. Some foods, we readily absorb the nutrients more than others. That is what we'll be discussing in that section. And it's important because, for example, if we have a protein-based meal, we would ideally like to absorb all of that protein. So let's say we are keen on building some new muscle. We want that protein, say like that, we want that protein to do stuff. That's why we want to absorb it. We want the dietary protein we have consumed to be absorbed by the body to do things like help us build new muscle, help our organs function properly. We don't just have to limit ourselves to protein. We could be talking about carbohydrates. We want carbohydrates for our energy, for the energy, for it to go to our mitochondria and our cells, for it to be broken down, and that broken down carbohydrate, glucose broken down to ATP, all that ATP used for our body to go through other processes, etc., etc., etc. And then finally, on the last slide, we will take all of the information we have looked at in these first three slides and we will apply it to I will, in a direct approach, explain how you can apply some of the information to your fitness goals or to your health goals. And with that all said, let's jump into the first slide. What and where is the intestine? The intestine is a tube that extends from the stomach to the anus. In this video, I am not going to do a demonstration on my own anatomy where the stomach and anus are situated. I'm daring to make the assumption that you're already at an educated capacity to understand where the stomach and anus are on the body. On top of that, I feel it'd be somewhat slightly inappropriate if I stood up, turned around and started trying to point to my hiney, my backside, my behind, my peaches. You get the image. I hope you don't get the image. You get the point. Stomach. The stomach is adjacent to the small intestine, and the small intestine leads to the large intestine. So you might not be as familiar with the intestines as you are the stomach and the anus. The small intestines and the large intestines are situated slightly below the stomach. If you pulled up an image on Google Images, let's say, it would probably come up with like a cartoon diagram where you can kind of see inside the body, see where the organs are. You'll notice that the small intestines are kind of scrunched up, they're folded in a strange way, and sort of as a perimeter around that, you'll see the large intestines. The reason that they're folded in this way is because they are trying to occupy a given amount of space, and that space isn't the biggest, and the intestines do a lot of work. Obviously, they absorb food, they break down stuff, they do a lot. And via these catabolic processes, they need room. They need room to work. And so they'll fold themselves in a certain way to occupy as much space as they can with what they're working with. The small intestines digests and absorbs food. We discussed this in the liver video. You'll consume a meal, you'll digest in your stomach, small intestines absorb that food. If it's carbohydrates, it breaks down into glucose. Glucose gets shipped off to the liver. If it's something like fat, it'll just go into the intestines, and then that'll get shot out straight into the blood circulation. I would like to elaborate, first of all, that fat will not just be immediately shipped out into the circulation. It does go through its own processes to be packaged into things like chylomicrons, but we'll discuss that in a future slide. The large intestines absorbs water and salts and breaks down proteins. So, yep, it does regulate water balance. The other thing the intestines do is they combat germs, and the large intestine in particular breaks down things like protein, and things build up, and once enough is built up and travel through the intestines, it's excreted out as waste via the anus. And lastly, the intestine wall contains lots of nerve cells. I've thrown that in there. I found it interesting. Maybe you will too. But when you are feeling stressed or anxious, you may notice that you get stomach pains, or you might feel when you go to the toilet that you're constipated, or the other way, having really bad diarrhea. And the reason it is because of nerve cells, because you have so many of them, and obviously they respond to stimuluses and stress, as well as feeling anxious, having anxiety, can cause a lot of these stomach issues. Before I get started on this slide, I have re-recorded this slide so many times. I feel like I'm rehearsing for a bloody show. I've said these lines over and over again. This slide, my God, trying to articulate what I mean, I've never found it a more difficult job. And it's not even the whole slide, it's the last point when I'm trying to explain fat, because it's such a pain in the butt trying to simplify processes, because you understand what you mean, but if you articulate it in a way that is even mildly incorrect or can be misinterpreted, it's like, oh. So now that I've said that, and I'm actually at a point of frustration with this video, I'm still happy though. Let's try and do this, hopefully for the last time. The intestine's role in metabolism. The intestine is a major site of digestion of energy-yielding nutrients, and it is a site of absorption of energy-yielding nutrients. We have enzymes in our intestines that further digest the already digested food we have consumed. These same enzymes are in our saliva. We chew the food, it gets mushy, we swallow the food, it goes into the stomach secretes acid, that broken down food gets absorbed by the intestine, and the enzymes break that down even further. This is all so the body has the best possible chance to absorb as much of those nutrients from the food we have consumed as possible. The gut is also a significant site of protein turnover. I talk about this in detail on the next slide, so I'm not going to talk about it here and now. Unfortunately, that means you'll have to wait until next week's video, so make sure to tune in for that. The gut metabolism requires a lot of energy and protein just to function due to sloughing of cells. The best way I can describe sloughing is if you imagine a snake shedding its skin. So this is kind of what the cells in the intestines and the gut do. Because there's a lot of catabolic processes going on, it's taxing on the intestines. The intestines have to resynthesize a lot of protein on a daily basis. It's like they are going through continuous repairs, whether that's due to the catabolic process of digestion, or or it's the process of resynthesizing new protein. All of it is costing the gut a lot of energy and protein to function. When you have a meal, let's say a high protein based meal, you can feel tired from that, and that's because certain protein foods are quite difficult, they're relatively more difficult to digest than other foods. The same could be said if you have a high fat based meal. You can feel quite tired after that, and that's because fat is energy dense, it's calorie dense. 1 gram of fat is 9 calories, whereas 1 gram of protein and carbohydrates are 4 calories. So if you add that up, if you have a lot of fat in one meal, that's a lot that the gut, the intestines, have to break down. And these are a few of the reasons why the gut metabolism requires a lot of energy and protein to function efficiently. The intestines also transport glucose straight to the liver. I have two videos discussing the liver's relationship with energy metabolism. So if you haven't seen those yet, make sure to go check them out. And finally, the point that I hate, the one that I have been trying to explain over and over again, and it just, every time I rewatch it, I go, no. This time I'm going to say yes. Nailed it. Big breath. Broken down fat in the intestine is repackaged and then sent off to the blood. So fat is a type of lipid. A major form of dietary lipid is triacylglycerol. What that is a glycerol molecule attached to 3 fatty acids. When you consume a meal that has fat in it, and it's broken down in the stomach and then absorbed by the small intestines, fat cannot travel via the circulation as free fatty acids. Now, I'm not saying number 3, I'm saying free, as in I'm free from jail. It cannot travel as free fatty acids. This is because the hint in the name is acid. They are acidic, and acids are harmful to the body. Therefore, they attach to other things, and they are packaged in a way that they can then be traveled. They are able to travel via the circulation. Usually it is that they are repackaged into a chylomicron, or TAG is packaged into a chylomicron, as well as other types of fat. I'm not going to go into detail of that. I'm not going to make things even more difficult for myself to explain. What you need to understand is it'll go into some sort of package, and then that's shipped off to the liver. Liver processes it further, and it'll go through different types of lipoproteins, blah blah blah. Not going to go into detail with that. What I am going to say is these. This is one reason why glucose is a more efficient energy source than fat, because glucose is stored in skeletal muscle, where so you might be doing a run and you'll be using the muscles in the arms, the shoulders, the legs, and those muscles that are being contracted, you have glucose stored in them. They're stored as glycogen. The glycogen's broken down, and that is used as energy. You do have some fat stored in between the muscle fibers, but not a lot. And what tends to happen is when your body starts to mobilize fat, so you've been working out for a little while, you've done a half an hour run, you're going for like an hour, your body will start to mobilize fat, but fat that's stored in the adipose tissue, it first of all has to be mobilized. It's not taken from the area that your body's working. It's just random. So it first of all has to be mobilized. It has to be packaged. It's shipped out to the circulation. It has to travel via the circulation to wherever it's needed, and then it has to be broken down. And all of this accumulates time, whereas glucose is ready. It's a lot quicker to break that down and convert it to energy compared to fat. And that's one of the reasons why glucose is a more efficient fuel source than fat. I think I did it. I think I said it all in the right way. Thank you. With that said, I'm going to end the video here for part 1 on the intestines. If you enjoyed this video, I would really appreciate a like. And hopefully you'll tune in for the second part, because it's the second part of these videos where we talk about applications, whether you're interested in sport or fitness or building muscle, powerlifting, whatever it is you're interested in. The second parts of these videos are usually where we get into the more interesting stuff. Anyway, thank you for watching, and take care, and I hope to see you next week. Until then, look after yourselves. Goodbye.